Hey, Batty. This is part two of 4.2, and let me share my screen to start off. The amazing formula, um, which I guess amazing in the sense that it's so reflective of something we learned before. Well, we learned before that you could use the derivative when we're dealing with plain old-fashioned derivatives, not the partials, but we were able to make an approximation, what we call it a linear approximation and or tangent line approximation, and we use the formula f of x is approximately equal to f of a plus f prime of a times x minus a, and that was when x was close enough to some given point a, some known point a, and a point that worked out convenient, and we use that much to our satisfaction. Well, now we're going to see a 3D version of this, a partial derivative version. And I want to just show it to you. I just want to show you the formula, then we'll do some problems. So when we approximate the value of, so we want to approximate the value of f of x comma y. So there's two variables here. Let's not forget that. Remember, there are two variables. So what we're going to do is we want to approximate this function value, and we want to find an AB that's close by, that's easy to work with and is close by. And we just want to get we have to know the value of f of a comma b, which is uh hopefully, which shouldn't be that hard if we picked a b well. Then here's the drum roll, please. F of x comma y is equal to f of a comma b plus fx of ab times x minus a plus fy of AB times x minus y minus b. And that's so eerily close to the formula that we learned in two dimensions. And so if you kind of notice what we're doing here is that we're getting the total change of f, and we're approximating it by adding the 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 approximate changes coming from both the x and the y direction. And that makes a lot of sense. That actually makes a lot of sense. Let's do an example. Let's do a few. We're actually going to do a few examples. So let's do this example right here. I want to use example. I want to use we're over here. I want to estimate f of x comma y, and x comma y is equal to x squared minus 4xy plus 4y squared. And I want to do it at the point 9.9, I mean 0.9 and 1.1. So I want to approximate it at that point. Okay, so let's do this thing. So what we're gonna say is like this. Well, first of all, we got to find the quote easy point, the a comma b. And I would say, these numbers are very close. These numbers are very close, to just a b. I would just let it equal 1 comma 1. Okay, now let's copy down the formula. Let's copy down the formula. That's going to be our target. So the formula is f of x y, f of x comma y. This is what we're trying to, just want to remind ourselves. F of x comma y. Actually, I'm going to write it in a different color. Is approximately equal to f of a comma b plus fx of evaluated a comma b times x minus a plus fy of a comma b times y minus b. And this is what we want to do. So we're going to need to find f of AB, fx of AB, fx of AB. Um, so we're gonna well, first of all, we need to find fx and fy. We actually did this in a previous problem, but it's not that hard. So let's find fx and fy. So fx, that's equal to, let's see, 2x minus 4y. And fy of, I'm sorry, of x comma y, that's equal to negative 4x plus 8y. Okay, and we explained this we explained this process. Okay, now I want to find fx of AB and fx of y, but I also want to find f of AB. So f of AB, let's just do that first. F of AB, I'm gonna plug in one. So it's 1 minus 4 plus 4, which just equals 1. So f of AB is equal to 1. That's good. Now fx of AB, that's gonna be fx of, oh, but I wrote AB. I should have written f of 1 comma 1. And fx of 1 comma 1 is equal to 2 minus 4, which is negative 2. Fy of 1 comma 1, that's equal to negative 4 plus 8, which is equal to 4. So fx is negative 2, fy is positive 4. And so these are the numbers that I'm going to be needing here. Okay, now let's do it. And what is anything else? No, I think we're good. FA, yep, we have everything we need. We have good. So F, excuse me, F. So F of, now I'm putting here 0.9 comma 1.1. That's going to be equal. That's approximately going to be equal to. We're over here. F of 1 comma 1, which is 1, plus fx of AB, fx of AB, which is fx of 1, 1, is negative 2, times x minus a, which is just x minus 1, which is plus positive 4 times y minus 1. But we're not, but we know what x and y are. We're at this point here. So this is equal to 1, and let's see, 2 times minus, I have a plus and a minus, that's minus 2 times 0.9 minus 1, 0.9 minus 1. And I'll figure that out in a second. And then we have 4 times 1.1 plus 4 times 1.1 minus 1. This becomes 1, let's see, minus 2 times negative 0.1 plus 4 times positive 0.1. And that becomes 1.6. So we use calculus. We use calculus. Now, by the way, I just want to just say, where does this come from? Where did this part right here come from? So that's, so 1 is f of 1 comma 1. plus fx of 1 comma 1 times x minus 1 plus fy of 1 comma 1 times y minus 1. And and again, this was that was 1, that was -2, that was negative zero point 0.1, that was y was 4, that's now was positive zero point 0.1. And again, the final answer was 1.6. And that's pretty cool and awesome. So we're going to celebrate now and do another problem with this approximation. It's pretty amazing. Pretty amazing because we're figuring out an approximation to a point in three-dimensional space. That's pretty impressive. Okay, now we're going to do another problem. So we have f of xy equals x squared times the square root of y. And we want to use this to calculate, we want to approximate f of 1.9 comma 4.1. Okay, well, I think it's pretty the to me it's pretty obvious that they want us to well, that's 1.9, that's 4.1, so that's pretty close to 2, and that's pretty close to 4. So we're going to use AB equals 2 comma 4, and we want to find f, and we need to know f of AB, x of AB, and fy of AB. So let's find, so f of AB, f of 2 comma 4 is equal to, let's see, 2 squared times the square root of 4, which is equal to 8. No? Now, what is fx? Fx, now this may seem like very hard, but it's actually not hard at all. Of x comma y, because don't forget, when you do partial derivatives, we treat the y like a constant. So it's really just 2x times rad y. It just comes down like any constant. And when I plug in 2 comma 4, that's going to be 2 times 2 times the square root of 4, which also equals 8. I like that. A lot of 8s here. And fy of x comma y, that's just equal to, again, the x squared is just a constant. So it's just x squared over 2 rad y. And f comma y of 2 comma 4 is going to be 2 squared over 2 times the square root of 4, which is equal to 1. So we're all good now. So we have our numbers. Oh, I had a cool highlight pen. I just gotta here we go. So here's my first one. It's a highlighter. So fy is 1, fx is 8, and plane f is 8. Okay. So now we're going to use our formula. We have everything we need now. We're going to use our formula that f of we're a 0.9, no, one, or is it 1.9 comma 4.1 is going to equal, we're just going to use the same formula right here. So it's going to equal, or it's going to approximately equal, I should say, f of a comma b, which is 8, and fx, which is 8, times times 1 point times 1.9 minus 2 plus 4, I'm sorry, plus 1 times 4.1 minus 4. So this is equal to approximately 8 minus, well, this 0.8 plus zero point 0.1, which is I like that. 7.2, which is 7.3. That's our answer. How much fun that was. Let's see if I can get another one. Well, I probably need another piece of paper. Let's move this paper here. And here we go. Let's do. Okay, here we go. I have another problem, and here it is. So I want to use, I have f of x comma y is equal to the ln of 10 minus x squared minus y, which is some heinous, hideous function. Okay? And I want to find f of 2 comma 5. I'm sorry, not 2 5. F of, okay, so I'm going to let a be. I'm going to let that equal 2 comma 5, because that's close to 2, that's close to 5. And now so I'm going to need uh, f of 2 comma 5, fx, and fy. So f of 2 comma 5, that's just equal to the ln of 10 minus 4, right? That doesn't make sense. Minus minus 5. Oh, no, it does make sense. It was the ln of 1, which is equal to 0. So there's my first answer, 0. Um, and now let's do the fx. Fx is equal to, well, it's 10 minus x squared minus y, and on top we have the derivative, but the derivative is just negative 2x. Because again, we're treating as a constant, 10 is a constant, and that's my derivative. And fx of 2 comma 5, that's just going to be negative 4 over, well, also over 1. This is going to be 1, just like that was 1 right there. Okay. So yeah. So which equals negative 4. And let me highlight that. Let me verify highlighter. And then the last piece of the puzzle is Fy, and that's going to equal 10 minus x squared minus y. That's going to stay the same, and the top is going to be negative 1. And this is just going to be negative 1 over 1, which equals negative 1. So there we go. Let's just highlight that. So we have it here. So we're using our formula now. Where did it just go? The formula. This is the formula right here, in case you've forgotten it. So f of we're over here. 1.8 comma 4.8. Approximately FAB, f of AB, which we got was 0, times fx plus fx, which is minus 4, times negative 0.2. Why is negative? Because that's 1.8 minus 2, which is negative point 1.8 minus 2, which is negative 0.2. And then minus 1 times 4.8 minus 5, which is negative zero point 0.2. And this is roughly positive 8, positive zero point 0.8 plus positive zero point 0.2, which is 1. And that's my answer. And there you go. And that's pretty amazing and remarkable. And that would be a approximation. And that might, oops, I don't want to do that. And that, my friends, is the end of the show, the end of the video. And we're going to continue next time. Bye, everybody. It's been loads of fun. Bye.